Hello, so this is my bonus task GeoGebra experiment. Here we have to explain the concept of law of large numbers using this experiment. This is the website. It has we can select how many flips of coins we can do. We can do 1 flip or 10 flip at a time. We can reset. We can do 1 flip. We can select the number of coins we want to flip. It can be 1 to 8, and we can select the theoretical probability of the heads. Means we can select it as 0.5, which gives us equal chance of getting head and tail, but we can reduce the probability of heads. We can also increase the probability of heads. So let's start with 0.5, which is what happens in normally when you do a coin flip. You have the probability of head being 0.5. So let's start with 1 coin. So let's first define what is the law of large numbers. So law of large numbers states that in a random experiment, when we are increasing the number of trials for a random number of times, for large number of times, what happens? The sample mean that we get from the experiment is equal to the theoretical mean. What does that mean? The theoretical mean usually that it will occur in a head is 0.5. There is 50% chance. But when we are doing the coin flips for a large number of times, it will tend to 0.5. The mean will tend to 0.5. So let's start with the experiment. We select 1 coin and 0.5% heads, probability of heads. So let's do 1 flip. It lands on 1 flip. It lands on first it lands on 0, then 1, then again 0, then 0, then 4, 5. Then we start doing 10 flips, because for law of large numbers to take into effect, to explain it properly, we have to do large number of trials. So if we keep on increasing them, we can see that the number of zeros and ones, which means the number of heads and tails, are going to be almost equal, which means that if we do the sum of these two and divide by 2, it will means number of zeros and number of ones, we will sum them and divide by 2, we will get the theoretical mean, which is 0.5. So let's increase the number of coins now. Let's increase it by 5. So let's increase it by 8 to see exactly what happens. So we are doing 8 coins. We are doing 1 flip of 8 coins. So number of times the head comes is 3. Again we flip. Number of times the head comes is 2. Now we keep flipping. We can see that in the middle portion, number of heads is more. The total number of heads is tending towards the middle, which is 0.5. If we keep on increasing, we will see that we get a normally distributed curve. So central limit theorem is also tied to law of large numbers. So what is central limit theorem? It says that as we do a large number of random trials, the expected mean that we get, it follows a normal distribution. So what happens is we can see that it is following a normal distribution. So law of large numbers and central limit theorem are tied together. So law of large number is saying that the number of the mean that we get from all this, it will tend towards the theoretical mean, which is 0.5. Now if we keep on doing, we see that it is the uniform distribution, it becomes more uniformly distributed. So if we do the sum of all this, like 3 times 0 heads have come out of the 8 coins, 33 times 1 head has come, 136 times 2 head, like this, 318 times the 4, and 269 times 5 head has come. And again the number of heads, which is like 8 heads and 0 heads are least, 5 and 3. This shows that the graph gets uniformly distributed as we increase the number of trials, which means that as we increase the number of trials, the mean of all these numbers, they tend towards the middle, which is the mean. So if you do if you flip 8 coins so many times, like 1257 times, so the 4 and 5, 3, 4 and 5 will be coming most, because it is the actual theoretical mean, which is the half of all of this. So let's see, by increasing the number of the bias of the head, let's say we have a coin in which the theoretical value of the probability of getting head is 0.8. Now if we keep on the increasing the number of trials, we see that it increases. It is a normally distributed graph again with a negative skew, because since the number of heads is 0.8, the probability of heads is 0.8, so the number of times that we get 6, 7 and 8 heads is more than getting the chances of 0 heads or 1 heads. So again, if we reduce the number of heads, the probability of getting heads to 0.2, which is the theoretical mean, we do the flips, we see that it is a positively skewed uniform distribution, which means the tail is towards the right, because we have reduced the probability of getting heads in all of these coins. What happens is, if we do 8 coin flips so many times, we see that the number of times, the probability that it comes with 1 or 2 or 0 or 3 lower numbers is higher. The sample mean is approaching the theoretical mean, so which is 0.2. So if we so in a normal distribution graph without any bias or without any skewness, if we do this experiment, we should get for 8 coins, we should get a properly normally distributed graph. So in beginning, the graph may not follow a normal distribution. Since we do starting, it will be less, and we will not be able to feel the uniformity in the graph. But if we do a large number, then we see that it becomes uniformly distributed, and the sample mean, which is that mean that we get from the trials of this experiment, is approaching the theoretical mean, which is 0.5, which is the near the center of the all 0 to 8. So both the law of large numbers and central limit theorem are proven by this experiment. Thank you very much.